So to determine if two functions are inverses, I need to check that f composed with g of x is equal to x, and that g composed with f of x is equal to x. So I need to check both inverses here. So let's first start with f of g of x. So that's going to be 4 over g of x minus 1. And what's g of x? It's x plus 4 over x. And so I can simplify this down, and I can say that that's 4 over x plus 4 over x minus x over x. So that gives us 4 over x plus 4 minus x over x, which gives us 4 over x, which is equal to 4 times x over 4, which is x. Okay, so that looks promising. Let's look at g of f of x. Okay, so I'm going to have 4 over x minus 1 plus 4 over x minus 1. To simplify this, I think I'm going to multiply the top and bottom by x minus 1 over 4 over x minus 1 over 4. And when I do that, I will get 1 on the bottom, and on the top I'll get, when I multiply this by this, I'll get 1 plus, and then when I multiply this by this, I will get x minus 1. And so that will give me x. And so they are inverses. Okay, let's try the next set. So let's look at r composed with s of x. Okay, so what's the function r? It's negative 2 plus, and then I'm going to put s in place there, over 6. And s is 6x minus 2. Okay, and so this is going to end up being negative 4 plus 6x over 6. So that does not look promising. Okay. Now I am given a one-to-one function, and I need to find its inverse. Okay, and so here I have the function y is equal to the cube root of 2x minus 5. And so the inverse function is going to do the opposite, so I can just cube the y and solve this for x. So I can add 5, and I can divide everything by 2. Okay, and so so there are a couple of ways I could write this. I could write this as f inverse of y is equal to y cubed plus 5 over 2. Or if you want to change the variable back to x's, we can write f inverse of x is equal to x cubed plus 5 over 2. So it kind of just depends on whether you want to write it using y as a variable or whether you want to write it using x as the variable. So just kind of a matter of taste there. The next one, I want to find the inverse, so I'll write y is equal to x minus 4 over x plus 2. Okay, and I want to solve this for x now. So what I'm going to do is I'm going to go ahead and multiply the x plus 2 over to the other side. So I'll have y times x plus 2 is equal to x minus 4. My goal is to solve for x here. So I'm going to go ahead and multiply that y in. So I'll have yx plus 2y is equal to x minus 4. And then I'm going to get everything that has x in it on one side. So I'll have yx minus x is equal to negative 4 minus 2y. And then I can factor out the x. And at that point, I can divide by the y minus 1. Okay, and so that's my inverse function. So I can write it as g inverse of y is equal to negative 4 minus 2y over y minus 1. Or if you want to switch it back and use x's, you can write g inverse of x is equal to negative 4 minus 2x over x minus 1. So, so again, it's just kind of a matter of taste there of what you would like to do. So you can check with your instructor as to whether you want the inverse to be written as a function of x or whether you want the inverse to be written as a function of y. So for the next one, I want to graph this exponential function, f of x equals 4 to the x, and use a table to find plots to point. So if I were to graph this, I can write x and then 4 to the x. And it's always good to have some negative and positive values. Oh, sorry. Let's do negative 1. Sorry. Let's do 1, 2, 3, and negative 1, negative 2, and so on. So if I do 4 to the 0, that's 1. 4 to the negative 1 is 1/4. 4 to the negative 2 is 1/8. 4 to the first is 4. 4 squared is 16. Oh, sorry. This is 1/16, not 1/8. And 4 cubed is, well, it would be 16 times 4. So what's that? 40 plus, so that's going to be 64. 64. Okay. And so if I graph that, I can see it's going to get huge really fast. Okay, so I'll just graph 1, 2, 3, and then I'll put on here 5, 10, 15, 20, and so on, and then negative 1, negative 2. Okay, so if I were to plot some points here at 0, the function is at 1, we're at 4, 2, 8, or sorry, 2, 16, excuse me. Why do I keep doing that? 2, 16, because 4 squared is 16. 4 squared is 16. And then the third would be, it's going to go like that. And then at negative 1, we're at 1/4. And then 1/16, and so on. And so it's going to have this asymptote like that. Okay, it's not going to cross there. And then I want to write the domain and the range. So the domain is all of the x values. And you want to write it in interval notation. So negative infinity to infinity. And the range is just going to get, the y values are going to get just closer and closer to 0 as we go out to negative infinity on the x. And so it's going to be at 0 to infinity. And we're not including the 0 there. So we have a parentheses to exclude that 0. The next one, I'm given the graph of f of x equals 1/2 to the x. And I want to graph 1/2 to the x minus 3 plus 2. So let's think about what these translations are doing. This one is moving to the right by 3 units, and then this is moving up 2. Okay, and so I can plot this point M that I have here, and I want to go to the right 3 units, so 1, 2, 3, and up 2. So that's here. Oh, wait. Let me look at the scale here. Up 2 would be off of my graph here. Hang on. So the right 3 and up 2, so it's going to be at 10 now. And then this point here is going to go to the right 3 and up 2. So it was at 0, 1, and then it's going to be at 3, 3. Okay, and let's just do one other point. So let's do this point here. So we're going to go 1, 2, 3 to the right and 2 up. Okay, so now we can plot that. And then the asymptote, again, is going to be, was at y equals 0, but it's going to shift up 2. So the asymptote is going to be here. Okay. And so we can plot the graph here. And so that's with those shifts included.